Welcome. So, in the previous lectures, we have discussed regarding the basic EOQ model. In this lecture, I'm going to talk about the EOQ model with plan shortages or the back orders. So, as we know that in a basic EOQ model, we have certain assumptions. Considering those assumptions, we have developed how we can find out the economic order quantity, okay, and how we can find out the reorder point, how we can find out the number of orders we have to place for the particular time period in order to meet the demand. So the assumption was the demand was constant, the lead time was constant, and no stockouts are allowed, which means no back orders are allowed. Okay. So in a economic order quantity model with plan shortages, all the assumptions are there which we consider in a basic EOQ model, but only one assumptions we are relaxing, that now we are allowing the stockouts, or you can say the back orders or the plan shortages. So for that, how we can represent graphically, that is, so on x-axis we have a time, and we are considering time as a continuous vector, whereas on a y-axis we have the inventory level. Okay. And if we are saying that if we are going to place the order equal to q, okay, so that is this one. So what would be the maximum inventory level? That is going to be q minus s. So s is the shortages quantity, which is the planned shortages quantity, which we will calculate that how much the planned shortages we should keep, okay, in order to minimize the total cost. And the maximum inventory level would be q minus s, that is the inventory we are going to place the order minus the shortage quantity, that would be the maximum inventory level we have. Okay. uh, so this is a demand rate. So as we already know that this part is known as the order cycle time, okay, which means that every cycle how long would it take to complete one order cycle. So this is going to be the second order cycle, this is going to be the third order cycle, and so on. So every order cycle which we are representing with T can be divided into the two part. One is the T1, that is the time period in which we are basically having the inventory, or you can say in which we are holding the inventory. Okay, and the second time period, which is a T2, in which we have the shortages of the inventory, or you can say the shortage time period, right? So how we can calculate these T's? So as we know that the order cycle time we can calculate, that is the optimum order quantity divided by the demand. Okay. So if we are using the annual demand, so you can use over here is the annual demand. That would be indicating that in order to meet the entire in the entire time period, what would be the order cycle time of the first, same is the second, same is the third, right? And then how we can calculate the T1, that is the time in which we having the inventory, that is going to be the inventory level. So the inventory level is q minus s divided by the d, that would be the time period in which we are having the inventory, right? T2 would be the time period in which we have the shortages, that is going to be the s by d. Okay, so that is the time period in which we have the shortages. And we know that in order to meet the demand, how many number of time we have to place the order in order to meet this demand. If this is the annual demand, then the number of orders per year would be the capital D over Q. Okay, so as we have discussed, the maximum inventory would be, in this case, would be Q minus S. So the rest of the notations we are using, this is capital D is basically representing the constant demand rate per year. CO is representing order cost, okay, per order. The similar CC is representing the inventory holding cost, or you can say the carrying cost, and CB is representing basically the back order cost, or you can say the shortages cost. The rest of the assumptions are the same, which we, as I have discussed earlier, that in a basic EOQ model, that there is no quantity discount are allowed, lead time or the setup time is basically constant. Okay, the plan shortages are allowed in this model, which we are considering. Now, in order to find out that what would be the total cost, what would be the carrying cost, what would be the order cost in this model. So in order to calculate that one, we are basically considering one cycle. So once we calculate the one cycle, then we can calculate over the time what would be the total carrying cost, what would be the total order cost. So first of all, in order to calculate the carrying cost, we know that the T1 is the time period in which we have the inventory, and how we can calculate T1, that is going to be the maximum inventory divided by the D. So Q minus S by D would be the time in which we have the inventory, and then this time is going to be multiplied with the average inventory over the time we have. So what would be the average inventory? So that is going to be the maximum inventory we have divided by 2, that is the average inventory. Okay, so if we multiply by it with the carrying cost per unit, okay, or you can say holding cost per unit, so this is going to be the carrying cost per cycle. So here the per cycle means for per T1, right? This one, or you can say even this capital the overall T. So for this one cycle, the carrying cost is basically equal to this one. Same is the case how we can calculate the shortage cost, which mean for the T2, that is the per order cycle, that is going to be T2 is basically the time in which we have the shortages, which is SD. And what will be the average shortage quantity in this time period would be S by 2, because the S is representing the shortages quantity, CB is representing the back order. So if we multiply with this one, we will get the back order or the shortage cost per cycle. Okay, and what would be the order cost? That is going to be C naught per cycle, right? Okay, so in order to calculate the total cost, so we can simply add it up: order cost, shortage cost, as well as the carrying cost. So if I divided this entire per cycle with the cycle time, which is going to be the Q by D, that is basically, or you can say if we multiply by this one with number of order per cycle per year, or you can say uh, we divided it with the T, that is basically the order cycle time, we would be able to get this total cost function. So if when we are going to multiply this one D by Q, so this is going to be the total order cost, or you can say in a manufacturing environment total setup cost. So this is a shortage holding cost, this is a shortage cost, and this would be our total cost. Now, once we know the total cost function, now our ultimate objective is to find out the optimum order quantity and the optimum shortages uh, quantity. Okay, in order to find that, we are using the same concept which we have used in the basic EOQ model. That is basically this cost is a convex function, and we know that for a convex function, in order to find out the optimum order quantity, because our objective is to minimize the total cost, so what we are going to do is we are going to differentiate this entire function with respect to S, and we will place it is equal to 0, and where we would be able to get the value of S star. This is the shortage quantity we can get. Okay, and after that we are going to take the second order derivative with respect to S. Okay, and if the second order derivative is greater than or equal to 0, then we can say that against this S quantity, this total cost will be the minimum total cost. Okay, okay, that is basically this one. As we can see that higher the quantity we are going to place, lesser the order cost as well as lesser the shortage cost. Higher the order quantity we are going to place, higher the carrying cost. So we need to find out the trade-off, which means we need to find out this minimum total cost. Same is the case in order to find out the optimum order quantity, which is Q star. So in order to find out the Q star, we are going to again take the first order derivative with respect to Q and put it is equal to 0. We would be able to get the optimum order quantity. And then once again, once we get the first order derivative with respect to Q, then we will take the second order derivative with respect to Q. If the second order derivative is greater than or equal to 0, then we can say that against this optimum order quantity, we would be able to get this total cost minimum. Okay, so if I would like, I hope you got the idea how we can find out the optimum order quantity in economic order quantity with planned shortages, or the back order as well as the shortages quantity. Now let's compare it, if we have using the simple basic EOQ model, or if we are using the EOQ with planned shortages. And this is the data we have, which means we have the annual demand, that is 10,000 per order cost per unit carrying cost. We have the back order cost. Okay, so if we calculate it, so we know that the total cost in a basic EOQ model, and this is the total cost function for the plan shortages. So based on this data, if I'm using the basic EOQ model, the economic order quantity would be equal to this one. But if I'm using the plan shortages, the economic order quantity would be equal to this one. So this would be the shortage quantity. So what we are seeing that, so no matter what kind of data you have, whenever you are going to use the economic order quantity with planned shortages, your Q star is always higher than to the basic EOQ model, right? So due to that one, because the optimum order quantity is higher than from the basic queue model, that's where we are going to place the lesser or the smaller order, which will decrease the number of orders. So if the number of orders is going to be decreased, okay, then ultimately your carrying cost would be going to be increased. And over here, okay, so what, as we have seen in the previous slide, so in basically in a plan shortages we were trying to basically taking the balance between the carrying cost must be equal to the order cost as well as the shortage cost. Okay, so which we can see over here, the total cost is over here is this one, whereas the basic EOQ model, the total cost is going to be this one. So this is the order cost. So this is the order cost. As we can see that the order cost is reduced. Okay, as well as over here we have the carrying cost, but we have over here is the carrying cost is going to be equal to this one, but this is the back order or the shortages cost. Now as per your scenario, you can evaluate that whether I should use the basic EOQ model or whether I should use the EOQ with the planned shortages. As we have seen that the optimum order quantity is always going to be higher in the plan shortages compared to the basic EOQ model, as well as the number of order we are going to place lesser compared to the basic EOQ model. So thank you so much. See you in the next video.